Hey everybody, this is going to be a lecture video for chapter 14 for our FPP 101 course, and today we're going to be talking about database programming, and this whole chapter is kind of a transition into your next class, SQL 101. So we're just going to talk about what databases are, what are DBMS or database management systems, and about SQL or SQL. Okay, so let's begin with talking why we would use databases in general. Well, once you go into the workforce, into the work field, you will realize that the amount of data that the regular company has is so big. It's so much larger than any of us can imagine, and there is multiple different databases storing multiple rows of data just about employees, about customers, about literally anything. And just because the amount is so large, we cannot just store it in files. Remember, we covered a topic about files and how we can store some information in files. Well, storing stuff in files is only suitable for a small amount of data, such as a grocery shopping list, or a video, or a picture, or a song. That can be stored in files. However, if you have a whole playlist, if you have multiple playlists of songs, those will be stored in a database. Or for example, if you're working in a company, you have to store information about every single one of your employees. And for example, you have 200, 300 employees, you will not be able to store all of that information in a single file. That's where the databases come in. So, databases were created to store large amounts of data, and database management systems came shortly after that to ensure that working with a database is simple, is easy, and is efficient as much as possible. Now, what is a DBMS? DBMS stands for Database Management System, and it's just a piece of software, there's many of them, a piece of software that helps you work with a database, with the amount of data that is inside of that database. You can manipulate data, you can delete data, you can insert data, you can do multiple things using a database management system. And let me show you how that works on an example. So you will have, in this class is Python. So we have a Python application right here, Python application. After that, that application will send some sort of command to the database management system. Now, once the database management system receives that command will be executed on the data that you have inside of your database. So it's pretty simple. You send what you want to do, database management system executes it, and then whatever action you performed on that data is being sent back to your application. Now, in this course specifically, we're focusing on SQL or SQL, and you will have two more classes focusing specifically on SQL because this is the most common database management system used worldwide. And it's very simple. It's not that hard to learn, not that hard to understand. It's just a matter of repeating exercises, and the same thing as in just regular programming. You just need to know the right keywords, and you need to know what those keywords stand for and what they perform when you execute them inside of your database. So, what is SQL? SQL stands for Structured Query Language. What that means is basically it's a programming language, but you will be writing queries. Instead of writing programs as we do in Python or Java, you will be writing queries. And those queries are what we call the execution statements, and those execution statements are going to be manipulating your database. Your SQL statements that you're going to be writing in Python, those are going to be passed down to your application, to your database management system, using what we call API method calls. It is not really important right now. The only thing that you need to know is what SQL is, what it stands for, and why we use it. Now, your DBMS, your database management system, will store certain data inside of a database. Now, a database is organized into tables. You can have one or more tables inside of a singular database. Now, that table will be divided into rows and columns, and it will be related. And by related, I mean that each row will have the same amount of columns, and each row will be assigned a certain value. For example, one row will stand for one employee, second row will stand for another employee, and so on. And then each column will stand for a certain characteristic or a certain piece of data about that row or about that item. So for example, if we have a row for an employee, one column can be their name, one column can be their age, another column can be their social security number, and so on. This is how it looks like. This is how a table looks like. So we have rows right here and we have columns right here. So pretty simple. Here is an example of a filled-in table. So we have a table that will store names and phones of certain people. As you can see, the first column stands for name, the second column stands for phone. And in the name, we have Katie Allen, Jill Ammons, Kevin Brown, and so on. And we have their phone numbers right here. Each column will have its own data type. So as you can see here, these are all of the data types that exist in SQL. There is a null. Null stands for nothing, so it's unknown value or none. Then we have integer. You're familiar with integers, just a number. Then we have real, which is a real number, which is a decimal number. We have text, that will stand for string. And we have BLOB, binary large object. And just think of it as literally anything. It can be any object whatsoever. There is also such thing as a primary key. A primary key is a unique column that will hold a unique value for each one of the rows. So that column will not have any repeating values. Therefore, it is unique. That's why we call it a primary key. A primary key is used to identify a specific row. So for example, if we have employees, a table of employees, their social security number will be their primary key because not a single person has the same social security number. So the social security number column will be the primary key for that table. There is also such thing as an identity column. An identity column, the only difference is that identity column is generated by the database management system. You do not have to do anything. It is generated by the DBMS. And usually it's just integers and that are auto-incremented. So 1, 2, 3 for each of the rows, for example. Identity column will be created if your column does not have a primary key. So if your table does not have a primary key, this will be created automatically for you. There is also such thing as null values, and sometimes it is okay to have null values in your column. For example, if you have customers, right? If you have a table for customers and some customer did not enter their address or something like that, that is perfectly fine. You don't really need to know the address of your customer unless you actually specify that the customer needs it. But if your company does not need it, it's okay to have a null value for your customer in that column. However, one thing to know is that a primary key cannot be null. So the only thing to know about the null values that is really important is that the primary key can never be null. Here is a typical process of using your SQL to connect to the database. So first step is to connect to the actual database. Then second, get a cursor for the database. And what that means is you're going to start at a certain point of your database. You're not just going to enter the database randomly. You're going to start at a certain point. Then you're going to perform operation on the database, such as insert values, delete values. Doesn't really matter what you're going to do. You're going to perform some sort of operations. Then you're going to commit changes to the database, such as, again, delete or insert or delete a table. And then after that, you're going to close the connection to the database. This is very important, but the idea is the same as when we're using files. The only difference is step number 2 and step number 3 and 4 that are going to be different. So we connect and we close the connection the same way as when we would open a file and close a file. Really quick, we will go over some basic statements in SQL just for you to get familiar. However, again, as I mentioned before, you will have a whole course for SQL, so don't get too worked up over this. I just need you to be familiar that this is SQL and this is possible to do in SQL. So the first one is creating a table. Creating a table is simple. You're going to put 2 keywords, create and table. Then you're going to put your table's name. It can be whatever you want, but it has to represent what that table is storing. For example, employees or customers and so on. So it has to represent exactly what is being stored. And then you have to specify the columns and the data types of that column. After you specify the column name and the data type, you will put a comma and you can put more and more columns. You can put as many columns as you want. And here's an example. We are creating a table called inventory, and we have 2 columns. The first one is item name that stores text or string, and then we have a column price that stores real numbers. So what it's going to look like, it's going to look like this. It's going to have only 2 columns. The first one is going to be item name, and the second one is going to be price. To specify that you want a certain column to be the primary key is very easy. All you have to do is specify which column you want to be the primary key, and you do it by putting primary key, all caps, after the data type of the said column. There is also such thing as not null. Remember how I told you that the primary key cannot be null? Well, you can prevent errors by putting not null after a certain column. So, to specify that the primary key cannot be null, all you have to do is add not null, 2 words, all caps, after the primary key. However, it doesn't have to be a primary key. You can also add not null to, for example, this right here. All you will have to do is just put not null right here instead of this comma and put a comma after that. That way, our column item name would not be null. You can also create a table only if it does not exist. So if the table does not exist already, and you want to check if that table exists or not, you can do this. You just put create table if not exist. So as I told you, SQL is very simple. It's very self-explanatory. All that you have to know is just the right words. But if you know what you want your database to do, or to have, you can pretty much figure out on your own, because as I said, if the table does not exist, all you have to do is just create table if not exist. That way, we will prevent duplicate tables in a side of our database. If you want to delete a certain table, all you have to do is just put the keyword drop, all caps, table, and specify which table you want to be dropped. And then also the same thing, you can check if the table exists and only then you can drop it. All you have to do is just check drop table if exists and the name of the table. Alright, now adding data to a table. If you want to add certain things to your table, all you have to do is put the keyword insert into, specify the name of the table where you want it to be inserted, specify which columns you want to have values insert into, and then put the keyword values and specify which values you want to be inserted into that table. Here's an example. We are inserting items 1, paintbrush, and $8.99 into the columns item ID, item name, and price in the table inventory. So in that case, item ID will be 1, item name will be paintbrush, and price will be $8.99. Now, if you want to work with values, if you want to retrieve some sort of values from your database, there is a select statement that is available to you. General format is keyword select, all caps, which column you want to select, one or more column, from, you have to put a keyword from, and which table you want those values to be selected from. Here's an example of that. In this first example, we are selecting the column description from products, and the statement will give us all of the values that are under the description column from every single row inside of our products table. Now here we are retrieving description and price from products, so we're retrieving two values. If you want to retrieve two or more values, you have to separate the columns by a comma. Very simple. If you want to retrieve all of the columns that exist in the table, all that you have to do is just put a star. Instead of putting the names of the columns, you have to put a star. Select star from products will give you all of the information inside of that table. So previously what we looked at was retrieving all of the data under a certain column or all of the data under a certain table. However, we can put certain criterias into our searches. We do that by using the where clause. So how does that look like? That looks like this. We have a keyword select, all caps, so it's the same idea, from which column we want to select data, from which table we want to select data, where, keyword where, all caps, and then we will put our criteria. I will show you an example of that. Here's an example. We are selecting everything, remember star, selecting everything from a table called products where the retail price is greater than 10. So looking at this, I can assume, I haven't seen this database, I haven't seen this table, I can assume that the table products has a column called retail price, so we are selecting all of the rows where the retail price is greater than 10. So again, it's pretty simple, nothing too complicated. I'm going to show you another example. Let's look at this one. We are selecting everything from products where units on hand is less than 100. So if we have less than 100 of a certain product, it will be displayed on your screen. SQL also has relational operators, and they are the same as in Python for the most part. Greater than, less than, greater than or equal, less than or equal, equal to. Equal to is, you can use it both ways, either a double equal sign or just single equal sign, and not equal to also has two ways of writing it, either the same way as in Python or using these arrows. This will also mean not equal to. There's also such thing as logical operators. Remember, we covered logical operators in PLD 101, and, or, and not. And you can also use them in your SQL queries. Here, we are searching for everything from a table products where unit cost is greater than 3 and units on hand is less than 100. So only if both of these conditions are true, only then information will be displayed for us. For or, again, the same idea, where we are searching for every single piece of information where retail price is greater than 10 or units on hand is less than 50. So what's going to be displayed is a row where either the retail price is more than 10 or units on hand is less than 50. And not works the same way. Select everything from products where the retail price is not greater than 5. So basically you can avoid doing that by putting the retail price less than 5. Less than or equal to 5. There's also such thing as the like operator. It's very useful for searching for substrings. And remember, a substring is just a part of a bigger string. So in this case, what we're looking for, we're searching for rows where the column description has the keyword bar in it. So it does not have to match bar, it just have to include a bar somewhere inside of that column for that row. The actual percentage signs, those are what we call a wildcard for multiple characters. So that just means that any characters can be either in front or after the word bar. Order by will sort your result that you're getting displayed to your screen. Order by is usually going to be sorted in ascending order. However, you can also specify to be either ascending or descending order. You will focus on that in the next class. I'm just showing you that it is possible to order your rows that are being displayed. So all you have to do is just put order by and specify which column you want it to be ordered by. In this case, it's retail price. So all of our rows will be displayed in ascending order based on the retail price, starting from the lowest up to the biggest retail price. Here's an example of that. We are selecting every single row from the table products where retail price is greater than 9, and we're ordering it by that same column retail price. So we're going to start at a price of 9.01 if it exists in that table, and we're going to go on to the max value that exists inside of that column retail price. There's a couple of mathematical functions that exist in SQL. The first one is AVG, which stands for average, and there's also a sum function. The average function will calculate the average value in a particular column, so it will display an average value from all of the values that are inside of that column, and the sum is just gonna calculate all of the values added together from that column. There is also min and max as well as count function. Min and max will show you the minimum or the maximum value found in that column, and the count will determine the number of rows inside of that column or inside of that table. So we looked at how to create values, how to create columns, how to create tables, how to drop tables. We looked at many different functions that exist in SQL, and now I'm going to show you how to update certain values inside of your table. So you can update a row using SQL. It's fairly simple. You're going to specify, you're going to put the keyword update, and you're going to specify from which table you want, in which table you want to update your value. Then you're going to put a keyword set, which column to which value, and you will specify where you want that value to be inputted into. Let's look at this example. So we are going to update some value inside of our table called products, and we're setting the retail price to $13.99 where the description equals chocolate truffles. So whatever the price was for chocolate truffles before, it's going to be overwritten, and now it's going to be $13.99. Here's another example. We are setting our description to semi-sweet chocolate bar where product ID equals 2. So what this query is going to do is going to look through your products table. It's going to look through all of the columns. It's going to find the product ID column. Then it's going to look for the product ID value of 2, and it's going to set its description to semi-sweet chocolate bar. You can also update multiple columns. All you have to do is just put a comma after the first pair of value and column that you want to update. So in this case, we're setting the retail price to $8.99 and units on hand to equal to 100, where the description has the word bar in it. There is also a way to delete certain rows. This is the general format. Delete from, 2 keywords, all caps, delete from. You will specify the name of the table as per usual, and then you're going to specify your criteria. Let's look at this example. We are deleting something from a table called products where product ID equals 10. So what this query is going to do is going to look through all of your table and find a column product ID, then find the product ID value of 10, and gonna delete the whole row, or whatever rows have the product ID equal to 10, those rows are gonna be deleted from your table. Another reminder about primary keys, the general rules that you have to remember. Primary keys must hold a value. They cannot be null, because remember, primary key is how we differentiate the rows between each other. So primary key needs to have a value. Each value has to be unique. No rows can have the same primary key value, and your table can only have one primary key. Your primary key does not have to be an integer. Your primary key can be anything else. In this case, it is a string, employee ID. It's text. See, we are assigning employee ID to the data type text, and it's going to be our primary key, and it cannot be null. It can also be a float, it can be a binary value, it can be an object, it can literally be anything that you want it to be. You just have to specify the data type of your primary key. Now let's look at CRUD or CRUD operations. These are the 4 basic operations that exist in a database and your database management system can do. So it can create, we use an insert statement for that. It can read, we use the select statement for that. It can update, we can use the word update, and delete with the delete statement. So you can create new sets of data, you can read existing sets of data from the database, you can update the existing set of data, and you can delete any existing set of data within a certain table. Now let's talk about relational data or relational database. Relational database just means that a certain column from one table can refer to a different column in a different table. So that way you can link the 2 tables together. Now why would we do that? To not waste any of our storage space, because if we are duplicating our data, that can lead to multiple problems within your database. And you can have conflicting data stored in the database, which is never good. Let's look at this table that has duplicated data. So as you can see here, we have duplicating data here, Austin, New York City, and we have duplicating data in a department, manufacturing. Now, in a relational database, we would separate that data into multiple tables. Let's look at this one. We would have a departments table, which would have department ID and a department name. Then we will have the employees table that would store all of the information about our employees, and we would have a location table that would specify the location ID and a city. And now let's look at this. These all 3 are connected. Department ID will be connected to the employee table right here, and then the location ID will also be connected to the employees table based on the location ID. Now, when we are adding a certain row to our main table, which is employees, instead of we're storing all of the information in it, we're going to store the department ID only, and then that department ID will tell us which department name refers to that department ID. The same idea with the location ID. We're just going to store the location ID instead of storing the name of the location, and whenever we need to find which city that is based on the location ID, we will look at the locations table. Another thing to know is foreign keys. Foreign keys is a primary key that exists in a different table. So, a primary key in another table that is being referred to in a different table will be called a foreign key. So for example, we have a primary key right here, department ID. In the employees table, it will be referred to as the foreign key. Same idea with the locations table. Location ID is our primary key here. However, it will be called a foreign key inside of our employees table, because remember that we can only have one primary key, and in the employees table, the primary key is the employee ID. And the last slide is our entity relationship diagrams, and it's fairly simple. In the diagram, one means that only one thing refers to something, and the infinity sign indicates many. So in this case, we have department ID 1 refers to many department IDs in the employee table. The same idea here, one location ID in the location table can refer to many location IDs inside of our employee table too. So that is it for today. Let me know if there are any questions. Reach out to me via email. However, this is just an intro to SQL. So you will have 2 more classes. As I mentioned before, you will have 2 more classes based just on SQL and how to use it. All right, I'll see you in the next video.